Thank you all for coming. This is Phoenix after 100,000 lines. Wow, this room is crowded. Like, there's even people standing. I'm getting nervous. First, who am I? My name is Renan Ranelli. I'm also known as Milhouse. There was a time in my life that I looked exactly like Simpsons Milhouse. Now I don't because I've got beard. I'm a senior software engineer at Sherpa. I work primarily with Elixir and ClojureScript. I've been doing that for 2 years now. And I previously worked with Ruby and C# mainly. And as if you have not guessed already, I'm not here from the US. That's why I have a weird name. I'm from Brazil, the homeland of the guy who created Elixir. And it's very nice being here, and very far away too. What are my objectives here today? I want to share, my objectives here are, I want to share my last 2 years experiences working with Elixir in a big application. And I'll show you guys what I mean by big in a second. I want to present and address some concerns we had when we started that endeavor, and what people might have when considering Elixir for more critical projects. We see many people using Elixir for that side project or some tangential stuff that's not critical. We want to talk about, we structure our business in Elixir. And convince you, my final objective here is convince you that it's great and safe to use Elixir and Phoenix for big projects. And when I say big, what do I mean by that? I have some shell incantation here that will show us, that I'll count all the lines in all the files that end with EX and EXS. And as of today, we have 100,000 and 1,500,000, that number here. Speaking numbers out of your native language is so weird, except when you're nervous. And how many dev modules do we have? We have 1,400 different modules in this application. So I think that this qualifies as big. Well, it's probably one of the biggest that I ever worked with. First, I want to talk a little bit about context. What am I talking about here? And I'm going to talk a little bit about the past so that you can understand how we got where we got and maybe why we got there. And our context, I work in an early stage startup. I was member of the founding team. I was the second or third employee, depending how you count the dates. I was one of the first employees in that company, and money was short. We're a B2B SaaS enterprise application, so we're not one of those scalability cases. I'm sorry, we don't need that many users. If we have like 1 million users, I would be rich already, and I would probably not be here. And a part of being an early stage startup, we also started in an early stage ecosystem. We started writing the application in June 2015, some time ago. Already in Elixir from day 0. And at that time, Elixir was 1.05. It is today 1.5.1. Phoenix was 0.14. Ecto was 0.13. And no one in the team had previous experience with Elixir, because I think that no one at the time had. I don't know of a company in Brazil that started using Elixir before us. Maybe if you know, please tell me. But I think maybe we were the first crazy guys to use it in production. And why didn't we even choose Elixir? Was it because it looks like Ruby and we were all Rubyists? No, actually. I was the only person in the whole company that actually knew Ruby. Because it's super fast? No. Because we needed to scale to 1 billion users overnight. No, if we scaled to 1 million, we would be rich already. Because we were spending a lot of money on machines. No, we didn't even have a product. How would we be spending money on machines? Oh, that must be because we understood the Erlang platform, weighted its pros and cons, and found out that it was the best fit for our needs. No, definitely no. That definitely wasn't the case. We thought we understood Elixir and, oh, it's just functional programming. It's just a functional dynamic No, we actually didn't. And you only really know if you know something when you try to do it, when you try to build something with it. And we discovered that we didn't actually know much. So why did we even choose Elixir in the first place? I don't know if that's an English word, but it means our ability to hire people. We, the problem space we're dealing with is Brazilian bureaucracy, which is like 100 times worse than American bureaucracy. And this is not some exciting place to be. It's like, oh, no one wakes up in the morning and thinks, oh, I'm going to solve some bureaucracy today. No, you don't do that. We quickly realized that we needed smart people to work in this very complex problem space. And we needed to give something to people to motivate them to work with us. And we thought, well, maybe if we use some cool technology, smart people will come and will accept to work in this not so shiny problem space because we have shiny tools. And in our defense, it may sound crazy, but there was another startup very close by, practically our neighbors, that they did the exact same thing with another language, and it worked very well for them. And we thought, well, we just can't use that language because those guys have a lot of money, and we can't compete with them, so let's find another language. And, well, we already had Elixir in our radar. We are good friends with the guys at Plataforma Tech who built the language, and we go out to get a couple beers every now and then. So we chose Elixir mainly because we wanted smart people wanting smile and invested people to work with us. So that's not the reason most people say, oh, I wanted performance, I wanted scalability. Well, we just wanted to hire people. And we decided to use Elixir as a lever. Like, we're going to give you a great opportunity to work full-time with this hot new thing and incredible people. Please listen to me. And now, some concerns we had when we started the journey, and we thought, what are the risks of those choices? And first thing, we will find libraries and other ecosystem-related stuff. We will need to build the world. That was one question we had. Will this whole thing turn out into abandonware? Like, will this language, will people surrender, oh, this ain't gonna work, and then we have our whole company based on a technology that is dead? That would be very, very bad. And how productive is this new framework? It's not even 1.0. How things will change? Should we be settling for something like Rails instead? We actually made that question. And will this be good for complex business logics, which we do have lots, because, you know, bureaucracy and stuff? Will this be stable in production? We don't want to wake up in the middle of the night because some alarm blew off. And more particular to our case, will our hiring strategy even work? Will there be people willing to work with this purple logo language? Our conclusion then was, well, we won't know unless we try it. Maybe in 2 years, we'll be able to answer that. And guess what? Here we are, 2 years later, waiting for some answers. As expected, we had lots of problems along the way. First thing that comes to my mind is interacting with other databases. For the relational case, we have Ecto covering us up very, very well. But interacting with non-conventional stuff, like at the beginning, we couldn't find good libraries to interact with Cassandra and Elasticsearch. And we ended up writing our own. And I can see some faces of, oh no, you did that. It's some fun work to do, but it's not the kind of work you want to do if you're an early stage startup. And today we've got Chandra for Cassandra. Cassandra for Cassandra. That's how you say it. But I don't know of any other good alternatives for Elasticsearch. Please ping me if you do. I really don't. It's not, dealing with Elasticsearch is kind of a different kind of beast, and it's not just, oh, you don't want just write queries. You want to transform your data to fit into those indexing stuff, and we ended up writing our own. It worked fairly well. And that was one problem we had. We had to rewrite some things that if we were in Ruby, there would be like 80,000 gens to choose, which is a different kind of problem. Authentication, accounts, users, all those stuffs that people need to log into a platform. At the time we were writing this, we couldn't find anything ready for use, anything that we were comfortable enough to use. We ended up writing our own. And by my face, you can guess, it wasn't really that good. But today, we've got a whole section in Awesome Elixir dedicated to just this. It's like you can choose, you pick up your flavor of authentication, accounts, users. You want something big, you want something more contained. You can choose. Like, this problem is solved today. One other problem we had, that this one was really, really terrible. I call it massive recompilations. With more than 1,000 modules, we discovered that it's quite easy to get in a situation where a big chunk of the project is recompiled after changing just one file on Phoenix. And I'm going to demonstrate that. I have here a project. I will touch a single file, only one file, and then I will compile the project. And now 238 files are recompiling. And this takes some time. I won't wait. We don't have time for that. But it's more than a minute until it, wow. And that's actually Phoenix Router's fault. It's the file that takes the longest to compile. It's because there's lots of metaprogramming magic happening there. And every time we change one file, we'd had to wait for a minute and a half to start running the tests. Where is the promise of fast? Well, we suffered a lot, but we got to understand the causes. We got to understand what caused those recompilations. There's and then I reached out to Jose himself and I asked, how do I know if something is going to be recompiled? And he himself wasn't really that sure. And then we made lots of experiments, talked with him a bit, and he said, well, why don't you write a blog post explaining people why these things happen? So I did it. It's probably my only blog post that has some relevance. And I did a talk at MPAX this year talking exactly about that. So if you're curious, wait for it to be released. Desmond is over here. He's on the organization. Ask him to release the video so you can see me. So that's it. Other problem we had, Timex's many major updates. Who in here uses Timex? Yeah, I saw your face. Yeah, there were many major updates in Timex, which is not actually a bad thing. It's good that things are evolving. The problem is that we started in a very early version, and many things changed. We started before naive datetime and datetime were even being discussed. Like, Jose himself, well, someday I will want to put those in the standard library, but not today. We needed a solution. Timex was there for us. And lots of those changes were in very specific cases. And as you might have guessed, we're HR. We deal with all sorts of legal stuff. And sometimes, like, 1 day difference in some computation can be a problem. So we had lots of complex logic depending on time. We kind of misused time zones too, and that hurt. Those many major updates hurt us. Timex now is very stable. It's very good library to use. So good thing that it passed, right? The thing has matured. And thank you, core team, for naive datetime and datetime diff. Yeah, really thank you. Other weird problem we had is a dependency clash. A dependency conflict. I don't know how to word this. Because Erlang lacked a HexPM alternative for quite some time, some different libraries declare the same OTP application name. That means you can have them both running at the same time. And unfortunately, there's no solution to this, and we got bitten by that. One of our dependencies two of our dependencies depended on different dependencies that had the same damn name. It was a UUI, one of those cases, the one that took us most of the time to solve was the UUID library that generates UUIDs. And both of them were called UUID. And there's simply no way to solve that. I opened an issue at the UUID library repository. I spoke with, at the HacksPM, namespaces, maybe namespaces can solve this problem. Well, I don't know. We ended up solving this in a very ugly way. We forked the dependencies, changed the names of stuff. Not proud of that, but deadlines. You did that too. Yeah. What a terrible place to be. Other problem we had, deployment of that 12-factor manifesto thing. It's a thing that Heroku wrote some time ago. And at those early days, deployment was a big unknown. No one had an answer on how to deploy Elixir things. And we had lots of trouble trying to mold releases into 12-factor compliance setup. We had weird behaviors with environment variables. We had all sorts of, oh my God, please help me moments. We ended up running Mix in production. And we're doing exactly that until today. Mix Phoenix server. Never fails you. And we had no problems since then. We had no problems. And I never had felt the need to, well, how is this release thing working out today? Because I'm not really needing it. So, and now I'm going to talk about some problems that were exclusively our fault. Had, like, not that the others before didn't had anything to do with us, but those I attribute more to us being noobs. First is joining the umbrella party way too late. Our app started as a single Phoenix app. I think that most people start their apps that way. And as the app grew large, when I mean large, like really large, we felt the need to split it to an umbrella application. Actually, we felt that need way before it grew large. But we kept delaying and delaying and delaying. And as you might have guessed, we weren't very well modularized, because if you have your application well separated, you have boundaries between your modules and stuff, it shouldn't be that hard to separate into an umbrella. But we weren't that well modularized. And we had lots of pain to get this done. I lost my last bit of hair doing it. But it was possible. It was our fault. We didn't actually prepare for that. So if you have a Phoenix application over there, please consider turning it to the umbrella as soon as possible. Fat controllers. Yeah, it's a terrible idea. Don't do it. We did it. It's terrible. Please see Chris's talk on Phoenix 1.3. It addresses exactly this problem and how the way he explains how the Phoenix generators were built, and wow, that's exactly how we started. That's exactly the feeling we had. You are describing exactly the problem we're having today. So watch his talk, understand why Phoenix 1.3 made the changes that it made. And after we had those fat controllers, of course, we tested stuff. We're not that cowboys. We wrote testing, but when we started to factor things out of we started to break down the fat controllers, we got lazy and did not write much of the unit tests. Like you extract a module from the controller, but you already have those completely integrated tests, integration testing passing through the controller layer, and you don't write the unit tests for that because deadlines. And because things were a little bit too coupled, that burned us. That burned us bad. Don't ignore the testing pyramid, right? You need to have unit tests. You need to have integration tests. You need to have acceptance tests. I've heard from people that get into the functional programming thing that, oh, you don't need mocking, so you don't need unit tests. Well, that's not true. First of all, you don't actually understand why you need mocks, but that's a conversation for another time. But uh, it is easier to test everything, integrate like end-to-end in functional programming because, well, it simply is. And there's people arguing that you don't need unit tests because of that, that integration level tests will get you covered. And one of those people was in our team. And we went with his argument, like, this guy is very experienced and he probably knows what he's talking about. And he actually did. But it didn't work out very well for us. And what's perverse about that is that in the beginning, everything was fine because the code in the controllers was concise, was short, wasn't that many edge cases, but that didn't last long. And when you realize that you're in that situation, it hurt. Don't ignore the testing pyramid. Write unit tests as you're factoring things out. When we start a new module, of course we unit test it, but in that breakdown point that I imagine, and I've talked with people that had a similar problem and got into this same spot of having two big tests covering lots. One of our mistakes was not using Ecto type. Who in here is familiar with Ecto type? Few people, yay, you're going to learn something good. We re-implemented most of Ecto type functionality very poorly because we did not read the documentation thoroughly. I trained to speak that word, thoroughly. And Ecto type is a behavior that defines functions for implementing custom types. And I'll show you an example of this. Oh, it finished it. An example of this. I wasn't so sure it would be. Of this going bad. In our system, we have a thing called CPF, which is a number in Brazil that uniquely identifies a citizen. It's like the social security number here. And we have this module and in our system needs to ingest data from various sources, and this data is formatted in various ways, and people use dots and dashes, and even I don't know how to say this in English, but the big dash, the long dash, it's called travessão in Portuguese, spaces, and we needed to validate this, and we wrote a contain module called validation CPF. The problem with this is when you actually have the CPF in a model, in a schema, you have here a field that says field number string, which is already weird. And the field number string is actually a very special string. It's a string with a CPF number. And there's rules associated with that number. And how did we even deal with this? In the change set, we got the number for the params, and we normalized it with our function that removes dashes, points, and everything. And then we validate the change with another function in that same module, asking if it is valid. If it's valid, do nothing, else put an error. The problem is you need to remember putting those two lines every time you mess with CPFs. And the problem with things that you have to remember is that you forget them. And we forgot lots of times. Another similar entity is the CMPJ, which is like the CPF, but for companies. This time around, we did the right thing. We modeled it as an Ecto type. We implemented the Ecto type callbacks, the typecast load and dump callbacks, which is everything you need to map a thing from the database to a thing in your application. Another thing that's good to say here, we're dealing with a high-level concept here that is an entity of the system, and we are reducing it to a string, a primitive type. And this is something I see a lot when people start functional programming. They forget how to abstract stuff. They get into this this movement of only using primitive values for everything. That's not a good idea. And given that this time around we did the right thing, if you look at the usage of this in the schema, it says field, CNPJ. It's not called number this time. And it says that it is special. It's not some whatever string. It is a string that complies to some rules. And everything you need to do to have it mapped is just put it in the cast, and then you're done. All the validation rules, all the normalization rules, everything will just work because people have thought about this problem. They have solved it before. Use it. Use that knowledge. Use Ecto type. And the other polemic thing we did was we migrated to a full single-page application and GraphQL API. We actually didn't finish it doing it. And we decided to re-implement the front end as an SPA. We got to a point where things weren't going as fast as we thought they should. And the solution to that was rewriting our API. And rewriting was not a good idea. Rewriting rarely is a good idea. And we had lots of problems with React, ClojureScript, GraphQL, reinventing HTTP features, yada yada. Things that you might have guessed we would have problems, and some have alerted us we would have that problem. And I could spend a whole afternoon talking about the reasons why we went that route. And if any of you want to talk about that, it would be a pleasure to tell you, don't do this. And in my humble opinion, that was our biggest mistake in this journey. And it was not a Phoenix or Elixir related mistake at all. I'll come back to this later. Hold that thought. Everything that I spoke here are incidental problems. There are problems that are not core to your business. There are problems that your client doesn't care if they get solved or not. There are problems that don't contribute to your customers wanting to give you money. And that's why we're all here. But we also had awesome surprises, and that's the time where I speak of good stuff. First, platform and operability. I was completely impressed. The more I understood about, the more I learned about Elixir and Erlang is how the platform is well built. It's like something built by engineers and for engineers. I won't delve much into that because Sasha Yurik has a great talk on exactly this topic, and he's much more knowledgeable than I am. And I urge you to watch this talk, and this is probably the best explanation as to why we're all here, why Elixir is great, that there is. Please go watch Sasha. He's not here, right? Too bad. Other thing, performance, and not only in production. There's this great article by José himself where he explains, he shares his vision on to why performance is important, and it is much more related to our developer experience, to how our day-to-day works, than only with production performance. He says that when you have fast tools, you're more happy because you don't have to wait 3 hours for the thing to recompile, and your tests run in parallel. And Elixir is concerned with that from day one. The people here who come from the Ruby community know that this is a problem for Ruby people. Like, things are slow. You can't parallelize stuff. You can't run things concurrently. Elixir thought of that from day one, and it really worked out. I was really impressed. Evolution. Libraries, ecosystem, events, people interested, everything evolved a lot since we started. When we started, it was like I would go into an event and who here ever heard of Elixir? Like 3 hands would pop up. And last month I was in an event in a college, and I asked, who here has listened about Elixir? And almost everyone in the room raised their hand. It was like, wow, this thing is really catching on. Things are very stable. Phoenix and Elixir were beyond stable. We even forgot to add restart on failure on our system.conf. It's like we ran months, and there were no random crashes. I would see a random crash a day whenever I was running Ruby with Unicorn. I was really astonished. No, I'm looking at the wrong service file. This is not possible. These things are really stable. And even though our app got really, really big, 100,000 lines, that's the catchy title, it was much simpler to work with than Rails and Spring apps of similar size we worked with before. Although it was big, you would be able to find a way around. You would be able to understand why some things are happening, because Phoenix is much simpler, not easier, simpler than those alternatives. And that was really nice. Contribution. We landed a lot of patches in many popular libraries. We got patches in Ecto, Phoenix, Cloud, Plug, JA Serializer, Timex. And that's nice, even though we were with the hope in the neck. You say that in here? So, we were very pressured to meet deadlines. We still were able to contribute to the community. We found a bug in the Elixir compiler. That was an achievement. We wrote some cool libraries, like a streamable zip encoder, some stuff that we needed. And we also got some other stuff that we should be able to extract in open source if we have a little bit more time. So even though we are in a new space, in a new community, given that things are simpler, we are able to look at the source code to contribute to stuff. I wasn't able to do those kinds of things when I was in C# world. I wasn't able to look at source code of a library I was using and understand what was happening. Oh, here is the problem. I never got to that point. And with Elixir, we did it like a dozen times. It speaks much about the power of the platform and how we all can contribute and make this a better thing. And our hiring strategy, it worked. It really did. We've got an awesome team of people. We've got people that would join the company exactly because we were doing Elixir, because we were talking at Elixir events. So it really worked. So after 2 years, what about our initial concerns, the ones I listed before? Will we find libraries a lot? We will need to build the world. Well, a lot before, a lot less today. But always try not to, please. Will this become abandonware? Hell no. Look at this room. How productive is this framework? Well, Phoenix is very productive. I'm very happy with Phoenix. I don't think Phoenix is like much worse than anything else. I think that some things are more verbose, some things have more ceremony to it, but in the end, it pays out very well. The simplicity pays out. Will this be good for complex business logic? Oh yeah, we had no big issues. We were able to transpose our knowledge from object systems to Elixir. I didn't talk a lot about this. I wanted to talk more about this when I submitted the talk, but I don't have time and I'm almost out of time here. Yeah, I have 5 minutes. I run. Will this be stable in production? Well, as stable can get. We were really impressed. And with our hiring strategy work, it did. So we can say, in conclusion, our biggest problems had nothing to do with Phoenix itself. The biggest problems we faced had more to do with shipping a product, with practices and teamwork and everything. I can't remember the time where I felt, well, this damn framework is in my way. I can't remember a time where I felt that. Except that time when the recompilation stuff that were actually our fault. But in 2015, Phoenix was enough to handle our needs. Today, it is even more so. Still lots of work to do, lots of opportunities to contribute, but if at that time it were sufficient for a startup, today it is even more so. Although Phoenix is new, it is very well founded. Phoenix is based on Elixir, which is based on the Erlang platform that has decades of proved success. Phoenix is built on the very many ideas that we experiment with Rails and other frameworks. We got a lot from that learning, from that knowledge. The problem that Phoenix solves is much more understood than the problems we have today, say, with JavaScript and SPAs and GraphQL stuff. Phoenix solves in a very elegant way a well-understood problem. So I've seen many people arguing against Phoenix, saying that, well, this is a risky technology, yada, yada. But I don't see that many people arguing against those JavaScript craziness we see today. I think that it should be the other way around. You should be much more concerned with rewriting your API and GraphQL stuff and the framework at the time in JavaScript than it is to use Phoenix. The thing is stable as hell. The thing works. It is productive. There's lots and lots of people getting involved, and more people getting involved. The community is growing. The ecosystem is growing. Things are more and more production ready and stable. So if I were to build it all again today, would I use Elixir and Phoenix? Hell yes. Hell yes, I would. The takeaway I want people to get out of this room is Phoenix is good for big enterprise applications. The following statement used to be very true. You're trading maturity and productivity for performance. Well, still a bit, but the amount of maturity and productivity we're trading for performance is getting smaller and smaller. The future is bright and faster. Thank you. Here are my contacts if you want to speak with me. I'm on Twitter, I'm on GitHub, I blog on Mihaus and Software. I'll be here the whole day. Feel free to reach out. Thank you. We have time for questions.
Is this working? Cool. We have time for, I think, 2 questions or something like that.
If you could change one, so you've written a lot of Elixir code. If you could change one thing about Elixir or Plug or Phoenix or Ecto or whatever, what would the one change that would make your life best today or this year, if there is one?
Wow, that's a tough question. Well, one of the things that I struggled the most was the slow compilation times for the router, because we had lots and lots and lots of routes. We're not going to have that many once we finish our GraphQL rewrite. But once you start getting many and many routes, the compilation time, I'm not very scientific on that, and it's quite some time since I last tested this. But the compilation time would grow linearly with the number of routes. So if you have 1,000 routes, you can break your routers down and stuff, but I would probably see to that.
One more?
Tough question.
When you said earlier that you had some misgivings about rewriting your app with GraphQL and single-page application, was the problem just with rewriting everything, or was the problem with choosing a single-page app and GraphQL?
Both, actually. Rewriting everything is bad, right? It's not really that bad in our case because we weren't actually changing much of the semantics, so it was more of mechanical, tedious work to migrate stuff from controllers to resolvers. It's not really that different. The main problem, in my view, is that we didn't actually understood what problem did we have, and what problem did GraphQL and single-page applications solve. So for most of our product, we didn't need the powers of a single-page application. Some pieces of it required some more rich interactions, and we would be able to solve that with React alone. One of the selling points of React is that you don't need to rewrite everything in React. You can start using it piece by piece. So I think part of that was the big effort in rewriting stuff. Another part is that we didn't actually understood very well what we were trying to achieve, what problem did we have. It was more of a, as you may have guessed, in 2015 we started using a framework that was even 1.0. So we're very adventurous, we like to take risks, we believe it's when you take risks that real innovation happens, but you need to have a backup plan. Just don't go to a route that you can't come back. That's kind of what we did in that regard. We survive, like we are solving stuff and everything, but it cost us a lot of money.
Okay, sorry, I know you have more questions, but feel free to talk to Renan during the conference because we have to continue with the next talk.
Thank you
Thank
so
you.
much.